This question is a Unit 2 question about solving cubic equations tech-free. There's a bunch of questions here to have a go at. The one that I'm probably going to do a demo is of question 2, part D, where it says to use the factor theorem to solve the following equation. So press pause, have a go, and then I'll walk through it. So this is the equation that we're trying to solve. It's a cubic equation, so there could be potentially just one solution, or there could be potentially two solutions if it does something like this, or there could potentially be three solutions if it's doing something like this. We're not sure what scenario it is, so we're going to have to do some algebra to solve it, and we're going to need to do more than just sort of rearranging like we'd solve linear equations. Our first step is actually to find one solution just by guessing. So usually the solution is between -3 and 3, so you really just have to try all those values to see if you can find a solution. I do them in this particular order because it's easy to substitute in 0, 1 and -1 and then try the bigger positive numbers first. So I'm just going to put 0 in all of these spots and see what happens. I'll have 2 times 0 cubed plus 4 times 0 squared minus 2 times 0 minus 4 equals 0. Checking if that equals 0, I've got minus 4 equals 0. That's not true. Okay, so x equals 0 is not a solution. I'll try with x equals 1, so 2 times 1 cubed plus 4 times 1 squared minus 2 times 1 minus 4. Does that equal 0? Let's have a look. 2 plus 4 minus 2 minus 4 equals 0. 0 equals 0, that's true. So I know that x equals 1 is a solution to that equation. So I've already found one of the solutions. Let's see what we can do with that. So the factor theorem states that if I know a solution, like x equals 1 is a solution, then that tells me x minus that solution is a factor of that cubic. So just relating this back to numbers, if I know that 2 is a factor of 14, that means I can do 14 divided by 2 and get 7, no remainders. Okay, so I'm going to be able to divide this cubic by this factor and get something without remainders that I'll be able to use. So I'm going to literally do the division similar to my normal long division. Okay, but I'm just going to divide this first term by x. So 2x cubed divided by x will give me 2x squared. So I'll write that up here in the 2x squared column. And then, just like I normally do with long division, we're going to multiply 2x squared by x minus 1. So 2x squared multiplied by x minus 1 will give me 2x cubed minus 2x squared, and that's what I'm going to subtract here. Okay, so I'm subtracting these two. Just like normal long division, subtract the bottom from the top. 2x cubed minus 2x cubed is nothing, so I don't write anything here. 4x squared minus 2x squared will give me 6x squared, and then carry the next item down and complete that same process. So 6x squared divided by x. 6x squared divided by x gives me 6x, so I put plus 6x up here, and then I'm multiplying 6x by x minus 1, getting 6x squared minus 6x. So that's what's going to go here. Okay, and then again subtraction. First two gives me nothing. Minus 2x minus 6x gives me positive 4x. And I'm carrying down this -4. So then the final one. Okay, I'm going to divide 4x by x. And that'll just give me 4. That's what goes up the top, a positive 4. And then multiplying 4 by the thing I divided by, x minus 1, which is 4x minus 4. Okay, 4x minus 4 here, and thankfully there's no remainder, okay, which is what we're hoping for. So if I'm doing normal division, so say that same one as before, if I do 14 divided by 2 and get 7, that means instead of writing 14, I can write 7 times 2. So I'll do the same thing with our equation. So instead of writing this big cubic, I can write it as x minus 1 multiplied by 2x squared plus 6x plus 4. Okay, essentially I've done a bit of factorization already. And then thankfully this is factorized just like with your quadratics. You can then say x minus 1 equals 0, or this quadratic equals 0. I can factor out the 2. And then I can actually factorize this quadratic as well. It'll end up being x plus 2, x plus 1. So I'm going to end up with a bunch of solutions. Okay, so my solutions will be x equals 1, x equals negative 2, or x equals negative 1. Okay, so in this scenario there's actually 3 solutions, and we found those other 2 just by guessing one of them. Okay, so there's a fair bit in there, using a lot of your skills from year 10 and year 11 that you've done so far. So good luck with the other sorts of problems. Should be able to solve them exactly the same way.